Hello and welcome to this introductory section on blueprints. So over the next few videos, you'll be learning what the blueprint is. Okay, what you'll be learning the blueprint editor interface. You'll be learning how to use events, functions, and variables. You'll be learning how to add an event, and you will be learning how to declare a variable among other things. And so what is blueprint? Just about every game engine has a scripting language that allows developers to add or modify functionality in their games. Now, there are some engines that make use of existing scripting environments, such as Lua, and some have proprietary or built-in, in-house built-in scripting environments. So Unreal Engine 4 provides two methods for creating content. When it comes to programming or when it comes to logic creation within content, it gives you two options. You can either code it out in C++ or you can code it out visually using Blueprint. Now, the Blueprint visual scripting system, it's quite a powerful and fully functional scripting environment that is used throughout the editor. It gives artists and designers the ability to create entire games, prototype ideas, and modify existing gameplay elements. And it, even though it's super powerful, but if you are working on a huge game, then it's not advisable that you use only Blueprint. You have to mix it along with C++ for efficiency. It does not mean that Blueprint is not efficient at all, but for certain cases, especially when you're working with big projects, C++ gives you a finer amount of control. But Blueprint, for the most part, for to a large extent, I would say, Blueprint does get the job done. And Blueprint, if you coming in from the older Unreal Engine backgrounds, so older Unreal Engines like UDK, they had something called the Kismet scripting system. All right. And Kismet scripting system was kind of limited. And at the same time, for coding, they did not have any C++. They only had something called Unreal Script, which is a scripting system that they built themselves. Epic Games built themselves. Unlike Unity, which uses C# for scripting, it also uses, I believe, it also uses JavaScript and Lua. So, not Lua, I believe it uses Boo, but there's a third language. The two main languages that are used by developers in Unity are C# and JavaScript. And C# is the most widely used language for creating content in Unity. While in Unreal, you have C++, the option of C++, and you have the option of Blueprint, which you have seen in one of the previous videos where we wrote a simple thing and you just got introduced to it. And I said that I asked you to just follow along and that we'll have a whole section dedicated to blueprints and introductory lessons on what Blueprint is and how to declare variables and everything, all the way up to creating some decent content using blueprints alone. Okay. So for this video, go ahead, if you're following along, just go ahead and create a blank project and save it wherever you like. And you don't need any starter content in this. So I'm going to be calling this Blueprint 01, okay? Because we might create more projects. I'm just going to call this Blueprint 01. And then I'll just hit create project and then wait for the project to be created. It should take about 2 minutes or less than that. Less than a minute, in fact, because we're not using any starter content. So it's already at 73%, 79, 83. So it's just zipping through. And there you go. So now you are inside this project. So let's talk about the basics of Blueprint. So developing in C++, it requires an integrated IDE or an integrated development environment, such as Visual Studio, Microsoft's Visual Studio. And they can be used to script anything from new classes and gameplay to modifications of the core engine components. Blueprint, on the other hand, is a visual scripting environment. Although you can't use Blueprint to write a completely different rendering engine, but you can still use it to create your own classes and gameplay functionality. And a visual scripting environment such as Blueprint does not need a traditional text-based environment, but instead it offers nodes and wires. Okay, so this is an introduction to what Blueprint is, and in the next video we'll start talking about more about how to use it. I'll see you in the next video. Welcome back. So to summarize, a visual scripting environment such as Blueprint, it does not need a traditional text-based environment. You're not typing out code, but instead you are dragging nodes onto the graph and then you're connecting them with wire. So nodes are visual representations of functions. So whatever you saw there, those little boxes there, they actually are little visual representations of functions. And obviously, function is a piece of code that performs specific operations. So it encapsulates a whole function of something. That's what a node does. And then it also encapsulates variables, not just functions, which are used to store data. It also encapsulates operators and conditionals. So in Blueprint, you use wires to establish relationship between nodes to create and set the flow of your Blueprint logic. That is, we use wires to establish the order of operations. So it's just like writing code line after line after line. So instead of actually typing anything at all, you drag and drop nodes and you connect two different nodes to establish a connection, which indicates the flow of logic from one end to the other. So, and the blueprint editor is the interface that allows you to make and compile these sequences. So every time you do something, make a change, you have to compile the blueprint, and then all the sequence of nodes and wires, they start functioning. And just a small note on when to use C++, because there will be a completely different section on how to use C++ within, how to use C++ within Unreal. So you only need to work in C++ if your game demands 100% efficiency or requires some modification to the core rendering, physics, audio, network engine components. And Epic has even provided, so the moment you download the engine, it is provided full access to all the source code that is used to create all the core engine components. Now, some people, if you are coming in from a hardcore text-based, some programming language background, you might probably only prefer using a text-based scripting or a programming environment such as C++. So if you are new to scripting, then working in a visual scripting environment like Blueprint is actually a great way to learn fundamental programming concepts without having to worry about syntax errors. Okay, and that was just a short note about when to use C++. And we won't get into C++ in this course at all. There will be an intermediate course on how to use C++ in Unreal and make games as well. So visual scripting allows artists and designers to script gameplay functionality, leaving programmers to work on the more complicated tasks. So a large percentage of most games can be created entirely in Blueprint, and there can be a small portion that can be relegated to C++. And because it compiles to the bytecode level, Blueprint scripts are still pretty efficient. So as the way people see, Unreal script that used to be used in versions until UDK or Unreal Engine 3 translated into Blueprint. So Unreal script was something like a script. It wasn't a great looking language as such, but it was still a script. You still had to learn a new language. You still had to type code. You would still make a lot of syntax errors and all that. So Unreal script morphed or evolved into Blueprint is a popular belief. And again, so Unreal script was married with Kismet, and then it gave birth to Blueprint, which is a lot more efficient, and it's also a great way to learn programming concepts without having to worry about syntax. And you can actually use Blueprint to make complete games for all the platforms that Unreal Engine 4 supports. But if you are working on a game that requires 100% efficiency, that's the only time you go back and work in C++, or it requires some modification to rendering, physics, audio, or network engine components, which is very rare. Okay, and even though Blueprint is a visual environment, Blueprint scripts still need to be compiled, and Blueprint scripts compile to the bytecode level, which makes it efficient. And it's important to understand some terms. First is the compiler. If you already are coming in from a programming background, then you obviously know what it is. And for the ones who are not coming in from a programming background, compiler is a software that is used to compile instructions or source code that is written in a programming language. So you write some code, you hit compile, and it compiles it for you, and then it goes to the process of compiling. That is the process of turning instructions into machine language or code that can be executed by the CPU. So since the CPU and the GPU, they only understand machine language, so compiler is a software that does the translation of your code, which is human readable, into machine code that can be read by the machine. So, and compiling requirements, they differ depending on the hardware and operating system. Then you have the bytecode, which is compiled source code that is processed by a virtual machine instead of hardware. Now, this means that the source code can be compiled once and it can be run on any hardware that has a virtual machine to process that particular bytecode. because the bytecode is the one which will anyways translate into machine code for the CPU and the GPU to understand, read and understand. Then you have a virtual machine. That's the software that translates bytecode into instructions. The hardware that's the actually the like from compile, when you use a blueprint, it compiles into bytecode, and then bytecode is compiled into machine code using a virtual machine. So there are two levels before it reaches metal, and so that the CPU and the GPU can understand what you have written. And so now let's understand what the blueprint editor is. It's it's the blueprint visual system, or the visual scripting system. It is a key component of the Unreal editor, and even in C++ based projects, you will most likely be utilizing blueprints to some degree. And there are 5 types of blueprints that you have to keep in mind when you're working in C++, working in Unreal Engine. So first is the level blueprint, which we probably already have seen what it looks like. So if you say open level blueprint, and if I open that, and this thing comes up, and I can just dock it here. So this is a blueprint node, as I was saying. So you click on a node, and this is encapsulated as an event, or as an event function. So, and then you can drag a wire and you can connect it to other nodes. Okay. So this level blueprint, it's used to manage global events for a level. For this particular level, which you don't have a name for, and which I believe I should be saving it. So I'm going to create a folder called maps. And inside maps, I'll just say hit Control S, and inside maps, I will say, I'll just call it main. I don't know, right? So now it's got a level blueprint for the level main, which will be only applied to the level main. So if you create a new map, then that level blueprint will go away, because this level blueprint is assigned to the main. That's why it says main level blueprint editor. And there's only one level blueprint for each level, so you cannot have another level blueprint, and it's automatically saved when the level is saved. All right. And then you have a blueprint class. That's a class derived from an existing class that has been made in C++ or from another blueprint class, and it's used to code functionality for actors that is placed in a level. And then you have data only blueprint. Now this only stores the modified properties of an inherited blueprint. We'll talk about all of these later. And then you have the blueprint interface, and blueprint interfaces, or BPI as they're called, are used to store a collection of user-defined functions that can be assigned to other blueprints. And BPIs allow other blueprints to share and pass data among each other. Okay, and they work pretty much like an interface in C++ or C# works. It's the same paradigm, the same programming paradigm that has been condensed into a visual scripting format, which uses nodes and wires to run the logic for different programs. As simple as that. Finally, you have the blueprint macros. Now, these are self-contained node graphs of a commonly used sequence of nodes that can be reused throughout other blueprints. That's the inherent nature of a macro. And blueprint macro are stored in a blueprint macro library. Now, if it sounds similar, because that's how macros function universally. Even if you take a macro in an Excel, this is how it functions, or Word, or any of the macros anywhere, this is how it functions. So anything that needs to be commonly used, they can be reused using a macro. It can be easily, like, you can record a macro, and if there's a function that that you have to use a lot, you record that as a macro, and then you just run the macro where you need to do it, so that you don't have to perform all those steps again. So pretty much the same thing out here as well. And that's the blueprint macros. And level blueprint and blueprint classes are the two most common types of blueprints that you'll use though. And we'll focus on becoming familiar with the blueprint editor, and later on you'll learn more about how to work with blueprint classes. So just a small note here: when you're working with blueprints, there are some basic terms that are good to know when you are just beginning to learn blueprint and programming in general. Blueprint is a class asset that's stored in the content browser. All right. Then you have something called a blueprint actor, which is an instance of a blueprint class asset that is placed in a level. So if I create a blueprint class here and I drag and drop it in the level, it becomes a blueprint actor. Otherwise, it's just a blueprint class inside your content browser. Then an object is a variable or a collection of variables such as data structure, such as data structures and functions that are stored in memory. And you have a class, which is a code template for creating objects, which stores initial values assigned to variables along with functions and operations that fundamentally define the class. And syntax in traditional programming and scripting environments, syntax refers to the spelling and grammatical structure, right? That is expected by the language compiler in order to be able to compile code into machine language. So there's nothing called syntax in Blueprint, but this is something that is related to the core traditional programming methods. So we have opened up the level Blueprint, and the workflows are easy to learn, but actually the scripting is not very easy to master. It's kind of difficult to master, but it's pretty easy to pick up, and you'll pick it up really well and quickly. And even though you don't have to worry about syntax in a visual scripting environment, you will still need to deal with logic and order of operations. So you can still get compile errors when it's missing some reference and you're trying to refer something. You're trying to hook some node onto some reference and it's missing some reference. Then it will still give you a compile error, but you'll never have a syntax error. But you'll still need to deal with logic and order of operations. And this takes practice in any coding environment, regardless of which coding environment you pick up, whether you're picking up normal text-based scripting or you are picking up something like this, which is a visual scripting method. You still have to deal with logic, right? And you have to keep practicing it in order to get it right. And then and the Blueprint editor interface, if I have to do a quick rundown, it has a menu bar, and it has a toolbar for quick access for common tools, like you can compile. So if I drag something here and I'll leave it, then you have to compile it every time you make a change to this graph. Then you can search for references to functions. Then you can check out the class settings here and all of these things. And then you can look for the class defaults. What are the class defaults and what's the tick interval and so on. So these are the global settings for this particular class. And then when you click on play, it opens up in its own little window, and we have nothing. So I'm just gonna hit close, right? And get rid of that. Okay. All right. And so class settings, compile, it compiles. And when you compile, there's this little arrow where you say what do you want to do when you save and compile. So you have three options. You can either say never, on success only, and always. Right. So it's not available for it's right now not available for level Blueprint. So let's say if I say print, okay, I'm just gonna say print string, and I'll just connect this. All right, and I just drop this, which is all fine. So if I say compile, and of course this compiles the whole thing, and now it has that. Even if I delete it, it still goes into this need to compile mode where it has this orange question mark, and you compile that and it goes away and it turns into a blue check if it compiles fine. All right, and you also have a details panel out here, and this details panel out here for showing properties of whatever is currently selected. So if I select even tick, obviously it's not going to show anything. So if I say I just bring in a constant, not comment. Okay, fine. I just brought in a comment by mistake, but it's enough to show you what the details look like. The details looks like the detail panel anywhere else. In the main, when you click on something, if I click on sky sphere, and there's a detail panel that comes up here. Similarly, when you click on any nodes here, if it has a detail panel, then it'll just show up with all the attributes of that particular selected node out there. All right. And then you also have a my blueprint panel. If you look at this, we don't have that here. This is I was just looking for that down there. So this is a my blueprint tab, and this is used to manage and keep tracks of node graphs and functions, macros, variables, and event dispatches. Okay, and so first you have the toolbar to just to reiterate, I'm just going to delete that and I'm going to recompile it. So you have the toolbar, which provides a number of buttons, and then you have the my blueprint panel, which is used to manage graphs, functions, macros, variables, and event dispatches, which are there in your blueprint. Then you have the details panel, which once a component, a variable, or function is added to a blueprint, you can edit the properties in the detail panel, which works pretty much like the detail panel anywhere. Then you have the event graph. This is the event graph, and this is where you script the core functionality for the blueprint. So all of these sections, pretty simple. So when working with level blueprints, though, the blueprint editor toolbar does not have a save or find in content browser function, because the level blueprint is tied to the level. So to save the level, you just have to save the levels. You just have to compile and it saves it anyways, right? And if I let's say if I say save and compile, if I just hit compile and I just go to file and I save all, it saves that, and that asterisk is gone. So there's nothing called uh, in other blueprints you'll find a button which has a magnifying glass which will take you to its location in the content browser. But here you don't have it because it's tied to the level. Simple. Now the blueprint edit toolbar you'll find only 5 tools. Okay, the two tools to focus on, we'll be focusing on the compile button and the play button for now. And so you can click the compile button to compile the script and see any issues in the compiler result window. If you have any, it normally comes at the bottom of the event graph. And then you have the play button and you have the same kind of play options out here. So if you go here, you click on this arrow, so you have these options. Similarly, you have the same options available for you out here, right? And so this compiles, this opens a find results panel with a search box. So if I click on this, so you can find results and all that. And again, I can get rid of this by clicking on that. And then you have the class settings, which shows the options for the blueprint in the details panel down here. Then you have the class defaults, which displays the properties for the blueprints, in the details panel. Then when you hit on play, it just previews the level for you. Okay, and of course, the my blueprint panel, it keeps track of all the node graphs, functions, macros, and variables, and event dispatchers that your particular blueprint uses. So if I create a variable here, let's say if I just create a variable here and I just say test, and we will talk about these variables later, but there you can see that this variable section is holding a variable that we just created. And if you can click on this to make this editable inside your level, but that's okay, we're not going to be worrying about that right now. So I'll just hit delete and we'll come back to the variables a little later, but just wanted to show you that you can add anything by clicking on the plus button here. Like if you want to add a graph, you can add a new graph. You want to add a function, or you want to override it, any of these functions, you can do that. Macros, variables, and event dispatchers. All right, and you can even rename it, and you can delete all these elements if you so like. So you can just the variable that we created, you can hit F2 on it, and you can rename the variable to whatever name you want. And so this is the event graph, and this is the default node graph that is used to code your blueprints, as we already mentioned earlier. And this is where you do most of your work when using the blueprint editor. And you can add more node graphs as such by clicking on the new graph to an existing blueprint as needed. And if you look at the node graph, it can be perceived as a sheet of graph paper. You can add as many graphs as you need to a blueprint to help keep it organized. So there are a few shortcuts that you can use within blueprint, and when you right click on an empty space, this opens up the blueprint context menu. And there's something called context sensitive, so which means that if I take it off, it says that okay, just take a look at this. If I just note this down, it says add event for SkySphere and a call function on SkySphere and create a reference to SkySphere. And if I uncheck this, it goes away. Why does it go away? Okay, for that, let's go back to the main level, and that's because SkySphere is selected. So if I select something like light source, go back here, and I right click, and you can see that it's changed to light source. So it's very convenient if you want to create a reference for something like a light source or any object or any actor inside the scene, inside the map. Then you click on that, go back to your blueprint. When you right click and if this is checked, then you can do a bunch of things with it. So even if you want to add an event for light source, then you can do that. And since it's context sensitive, you will find only the events that are specific to the light source. And you have the input section, and you have the call function on light source, what do you want to call, and so on. Okay, so that was a very quick primer. And then you can right click, right drag an empty space. If you want to, like, if my graph is getting really big, then I can just drag it around to pan what the graph looks like. Then you can right click on a node, which it brings up the node and pin action. So what all can you do with the node and pin action? So that's the node. And if I can also right click on this, not here, but I can right click on this and I can say promote to variable. We won't get into that yet, but this is gonna come up later on. So you can right click on the node to bring all of these things up, or you can right click on any of these individual output pins and you can promote them to variable, and you can do a bunch of things out. You can watch this value when you're debugging it, right? And then you can click on a node. Simple, you can click on node to just select it if you want to select a node, or you can marquee select to do a bunch of to select a bunch of nodes at the same time. If you want to move a node around, you select it and you just move it around, and you just drag it around with your left mouse button, right? And if you just do this, it's going to do a rectangular select. And then when you hit control, if you say control click, okay, control click, and it deselects it, okay. And then when you roll the mouse wheel, if you can like zoom out like this far, and you can only zoom in this far, so it's been clamped. And if you are like out there somewhere, like I like ventured out too far and you want to come back here, when you hit the home key, then you go back to the main graph and it just centers the event graph. And when you want to delete something, simple, just just select the node and hit delete, as simple as that. And again, if you can either hit control X to the same copy paste operations. So control X and control C or control V, control C to copy, control V to paste, and I'll bring this back. Now that's one little very useful thing that you can do. So when I want this, if I have a bunch of nodes and I want to duplicate them, so instead of doing control C and control V, which requires two different operations, so I can select that with this selected. If I want this same node out here in this empty space, I have my mouse cursor here, check my mouse cursor, and I hit control W, and this comes here. Now of course this says that it's a custom event and it gives me a warning, but that's how you duplicate your nodes. So I hit home again. Let's say if I'm creating a variable, and I'll just call this, okay fine, I'll just name it new var, and don't worry about this get set, we'll get into that. And with this new var, if I want to duplicate that, then, and if I want to duplicate it here, and I just with my mouse cursor wherever it is, if I hit control W, it pastes it'll paste that node where your mouse cursor is. Okay, pretty useful, and you'll be doing this a lot. Okay, so I delete that. And then we already spoke about the context menu, and which is we already spoke about the context menu, so, and which is context sensitive, which is extremely useful. It's extremely, you also find yourself using it a lot. And then you have of course, yeah, we'll talk about the nodes, wires, execs. This is called the exec or the executive pin, execs and pins. Now it can help to think of the flow of a visual script as electricity. So, and a red event node sends out a signal that travels along wires and executes whatever node it passes through. So when a node receives a signal, it retrieves any data it needs through data pins on the left side. It then performs its operation, passes the event signal along, and returns any results through data pins on the right side. So nodes are visual representations of events, functions, and variables, and are color coded to represent the use. So if you can see the color of this event, if I drag and drop this and I say set, and look at the color of this node and look at the color of this node. Okay, so you can understand these are all color coded to help you differentiate quickly by just looking at it at one glance. Obviously, you need to see a lot more nodes and practice a lot in order to differentiate them at one glance. So a red node is an event node, as you just saw, and it's used to initiate the execution of a sequence of nodes. You also have blue nodes, which are functions to perform specific operations. So I believe let me create a function, and there you have, it's a new function, and it's opened up in its own graph. Okay, and I'll just delete that, we don't need the function now. So I'll just delete the function, and I'll also delete the new var because we don't need that. I'll hit compile. Okay, so, and they also have multicolored oval nodes, as you saw, each with a single data pin. Those are variables. So variables are multicolored and oval in shape. They only have a single data pin, Blue nodes are nodes that perform functions, and a red node is an event node that is used to initiate the executions of a sequence of nodes. Just keep this in mind. As you practice more and more Blueprint, you will get it in. Okay, the whole idea will sink in. Then you have the in and out execution pins, or the execs is how they call it. They are these white little triangles, right facing. They always face right. They never face left, and they are always out there at the top of a node. That sequence that denotes the sequence flow, and a red event node has only an exec out pin. So because it's not taking in an input, it's only used to initiate a sequence, while you have blue nodes which have both in and out exec pins most of the time to pass the signal along. So blue nodes are the functions, so it takes in some input and it throws some output, and that's how it passes the signal along. Then you have data pins, which are color coded, which are based on the type of data that they need. And data pins on the left side of a node retrieve data, while data pins on the right side of a node return data. Simple. And then you have wires like this. They just connect. They just connect different nodes. So when you have a white wire, they connect in and out execution pins, and you also have colored wires which connect data pins. So the color of each wire represent the type of data it's passing. So if I bring in again, I'll create a new way. I won't delete it this time. If I put this in here, and if I select this, a wire, so you can see that this wire is red in color, but this wire is white in color because this is an execution pin. Okay, delete that. And to, of course, to establish a connection between an exec pin or a data pin with a wire, you have to click the pin, and you have to drag another pin of the same type. And to break a wire that is going in or out of a pin, so let's say if I do this and I just say print and print string, so this is made the connection between event begin play and print string. So this means that at event begin play, print the string, and that's it. This is how the flow of the logic is happening here. So if I don't want this to be connected, I just want this to be somewhere else, or I made a mistake, or I want to do something else, what I can do is I can hit alt, and I can just click on this to sever the connection. I can either click here or here. So if these two are connected, if I click on this, it goes away. Okay, or you can also control click plus drag and a pin, or move it to a new pin. So if I connect this, then I can hit control and I can just drag, and of course it's not going to go there, but you can see that I am actually taking it in, and if it had been going in, then it would just enter there. That's it. Okay, so I'm hitting control and I'm doing this. If I want to sever the connection, then I hit alt, I click on this, and the connection gets severed. Okay, so that was about all of these little variable things and all that. So in the next video, we will talk about the concepts and scripting itself, what the events are and how they work. Right, I'll see you in the next video. Thank you. Welcome back. So all coding environments make use of events, functions, variables, and conditional operators, as you know. So let's introduce you to some of the core concepts that are used in Blueprint, as well as the other coding environments, which is almost pretty much have an overlap on these concepts. So the first one is events. Again, most or all the programming languages use them, and blueprints in Unreal 4 actually are based on events. And an event is something that happens during gameplay and can be anything from the player pressing a key on the keyboard, or a pawn entering a specific room in a level, to an actor colliding with another actor, or even the game starting, or the game updating, or the game ending. All of these are events, and most events fall into common categories. Okay, and events are used to initiate a sequence in Blueprint. So this is used to initiate a sequence. So if I connect this to a print string, that's a sequence created right there. And when an event is fired, a signal is sent out from the event's execute out pin. It travels along this wire, and it processes any function that it encounters along the way, like print string. Okay, so to reiterate, it's pretty simple. When this event gets fired, a signal is sent out from the event's execute out pin that travels along a wire and processes any functions that it encounters along the way. So for instance, if I delete this and I bring in tick, event tick. I bring this event back, and let's say I just say print string, and it just prints hello, and it prints print to, I don't want it to print to log, and I text color is okay. All right. Let's see. So if I compile this, and if I come back here and just hit play, and you can see this that it's firing. So as I was talking about, now when an event is fired, so this event tick is getting fired and a signal is being sent out. So these are the signals that are being sent out from the events execute out pin, from this pin that travels along this particular wire, and it processes the print string function that it encounters along the way. So if this had some other if this had a wire going out from its exec pin onto some other function than that event, now this function will fire and it will travel the signal through the wire that's connected to that particular node, and you will also see something like this happening. And when the signal comes to an end of sequence of nodes, the signal is lost because there are no the cables connected from going out from print string connecting any other nodes for the signal to be carrying forward. All right, so I'm just going to stop that. Okay, and you can see that all of these hellos are printed, they'll just go away. All right, so first you have a begin overlap. Okay, I'm just going to get rid of this, or yeah, I'm just going to get rid of this. So you have an event called begin overlap. We don't have that here. That's because overlap, we can't find that here. That's because you have to select something like let's say a flow, I guess, and then I say overlap, and there you have add on actor begin overlap and add actor end overlap. So begin overlap fires when the collision hulls of two actors overlap, and it's assigned to an actor or a component. All right, and then you have the end overlap. This fires when the collision hulls of two actors stop overlapping. So when a guy walks into a volume or a trigger volume, so begin overlap takes in, begin overlap begins, begin overlap is fired, and whatever function has been, whatever function this triggers gets called because of this trigger. They get executed, things happen, and then when the guy walks out of the trigger volume, then this thing gets called, this thing triggers, and whatever cleanup operation or whatever thing has to be done based on the developer himself, that takes place. So pretty much the same as other programming languages where you have a begin overlap. So you can imagine this as an event which is inside C++, which is called on actor begin overlap and on actor end overlap. Okay, and the body of the code containing the content of the code itself, the behavior of the different actors, desired actors, right? And then you have something called hit, which fires when the collision hulls of two actors. So if I click and if I say hit, so you have add on actor hit. So this fires when the collision hulls of two actor touch, but they don't overlap, just touched. Okay, and this is again assigned to an actor or a component. So if you see that I have selected flow, that's why I'm getting all of these context sensitive events and functions. Okay, and then you have begin play. Begin play is not, doesn't have to be context sensitive, but this is just an event. So when I click on this, just like I brought in a tick, I can also bring in event begin play, and I can fire this event, and I can connect this to different nodes, and I can create my own logic if I want to. And then you have end play. There you have add on end play. This is actually for the flow. You can say on end play. So you can say, yeah, so that's event end play. There you go. This is a generic event end play, not for the flow. Okay, and so these are the 5 common events that are used, and there are 3 more, where you have destroyed, which fires when an actor has been removed from memory. Then you have tick, which we just saw a while ago, where we connected that to a print string. That fires with every tick of the CPU. Then you have something called custom, which acts as the user has defined it to work based on tailored needs. Now, some events need specific actors or components assigned to them, such as collision events. It is likely that more than one collision event is being broadcasted at a time. So, for instance, if you have a box trigger actor and a sphere trigger actor in your level, and you need each of them to respond when other actors overlap with either of them, you need to assign each to their own on actor begin overlap collision event. And being able to have events assigned to specific actors allows you to script each actor's individual responses. So to assign an actor in a level to a collision event, you select the actor in the level, and then you right click in an empty location anywhere in the event graph of the level blueprint. Then in the blueprint context menu like this, you can type on actor begin, on actor begin, or on actor begin overlap. So these actors are also inside collision, and you can see all of these events that we just spoke about inside the collision category. And inside the game category, you will find a bunch of and two other you know you can find a bunch of events out here: on take any damage, on take point damage, on destroyed end play. And under input, when you go to mouse input, so there are a bunch of things on touch input, so what happens when the floor is touched, and so on. And again, once the collision event node is placed, you can see the actor's name that is assigned to the event node. So if I say add event collision, so you can see that the actor's name has been assigned to the event here in brackets. It's called flow because we brought it in for flow, right? And when the actor's collision hull is overlapped after that event we placed, the the collision event node executes. Now, components, you also have components in Unreal Engine 4. Like, these are components where you can say you add component, and these are all the components. Now, for this particular flow, you have a static mesh component attached, so you can add as many components as you like to make it a chain of components, right? We won't be covering that now. We'll be covering that a little later. And while the blueprint editor provides predefined event nodes, you can also create your own custom events that can be called at any point in a blueprint sequence. And creating a custom event allows you to define the name of the event and any data that is passed when the event is called. So you have event begin play and on actor begin overlap that call a custom event, and pass a string variable. And then the custom event will receive the signal, and it can use any function like a print string function to display the received string data to the screen. Okay. And custom events can help you manage and organize your blueprints if you want to create those custom events. So to make a custom event, you have to right click anywhere in the graph, and inside the blueprint context menu that comes up, you just type in custom, and then it says add custom event, and you give a name for the event. So I can say something like my custom event or something like this. And there you can see that if you go over to the event graph, you can see the my custom event. All right. Now the my custom event, you have a bunch of things that you can do. You can say call an editor, you can say replicates, whether it runs on server, which is kind of advanced. We're not going to get into that. And then you can click on a new parameter, and you can click parameters here. What events do you want? Do you want this to be Boolean? All of these are variable types, which we will cover in a while. And then you can also assign a variable to the event. So we can select the node, we can add a variable, or you can even assign a variable. And after we have made a custom event, you can call the event from another sequence by opening the context menu. So if you can't double click this because it's not a function, you can open the context menu and type it in the search box by hitting right click in the context menu. In the search box, you can type for let's say my custom event. So there you can see my custom event, and it's got nothing but it's got no variable. So if I add a variable here, let's say I'll just add a variable for the sake of it, and it's a Boolean, and the default value, I don't know, pass by reference. Okay, so I just hit compile. When you hit compile, there you go. And now when I click on my custom event, and there you can see that the new param is out there. All right, of course this makes no sense, but whatever, just there. Okay, so I'm going to delete that. We don't need a custom event, and I think I'm going to keep that variable. You might need it. Okay, and obviously you can also select the custom event from the, we don't have the palette here, but if there's a palette here, you can actually drag and drop that onto the graph as well. Okay, next we'll look at functions. So function, like in any other programming language, if you have a background of programming at all, then you know that it's a piece of code that performs specific operations. It takes in data that is stored in variables, it processes the information, and in a lot of cases, it returns a result. Okay, or in certain cases, it does not return a result, but it just does something with the variables, but it does not return anything. So the Blueprint editor has a full suite of predefined functions that are similar to those in any other programming environment. So when a function is placed in the event graph, you can typically see a data pin on the left side of the functions node. And in a Blueprint, a target is typically a variable that stores a reference to an actor or a component. So if you could see that, I deleted that. If you remember that we search for my custom event and we brought in a node here, you could see a target to the left. Okay, so that's actually, it stores a reference to an actor or a component of an actor in the level on which the function operations will be performed. Okay, so moving on, let's see. So let's do a small thing here. I will be bringing in, let me bring in a sphere. I will go to the modes, I'll look for a sphere, and I'll just drag and drop this guy here. Okay, and I'll just put him somewhere like this and like this. I'll just keep him hovering here, and let me just hit play. If I can see the sphere, there he is. Okay, and now let's go back. I'm gonna click the sphere and I'll go back here, and first I'll bring in the event begin play. Begin play. No, begin play. There you go. So from the event begin play, I'm gonna drag a cable out and I'm gonna look for set actor location. No, first wait. First I'm gonna be bringing in, with that selected, I'm gonna be bringing in a reference. I'm gonna say create a reference sphere. Just follow along, and here we have the sphere, and I'll be dragging a wire out of this, and I'll say set actor location, and there you go. And this has to be then connected to this input pin, and the whole logic ends at this place. All it does is, when the game begins, it takes the sphere, and as you can see that it's connected to the target, and as we spoke about, that target is almost always a reference to an actor or a component from the level, and then it just sets the actor location because this is encapsulated with the function behind the scenes. Okay, and now whatever location you want, so I'm going to set it to that location. I'm going to hit compile, and I can see that this let me see where it ends up when I say 0 0 and 0. So he ends up right there, right? So let me move the player start. I'm gonna move this guy out here like this, so that I don't overlap him, like this. And then I'll be moving this guy somewhere here. Okay, and first let me see, I'm gonna save this. Okay, and content browser, save all. Let me save all. Let me hit play, and there you can see that it hasn't really come to. Okay, yeah, of course. So let's select the sphere, and inside the mobility, let's select it to movable so that it can move. When I hit play now, there you can see that this guy is back in the center. And if you want it slowly, I think let me do a delay. I'm gonna sever this out first, and let me do a delay. Let's say delay, and the delay can be of, I don't know, 1 second. And after it completes, then I'm going to connect that to the set actor location. I'm going to hit compile, and then let me just watch it come here. There you go. So after delay, it just comes back here. So now we can see that on event begin play. So if you want to read this whole thing, so on event on begin play, so as soon as the game begins to play, it has a delay of 1 second. Okay, that's always in seconds. And once it completes, it sets the actor's location. Now, which actor? So you have to refer to that by looking at the target and it's what node it's connected to. So target is blue and it's connected to the sphere because we brought that in from here. And then what location do you want it to be? Want the sphere to be set? I want the sphere to be set at 0 0. Let's say I want to set it at 0 0 10. Okay, and I hit compile, so I think it's going to be kind of floating in the air. So there you have, that's 10. I believe it's at 10. Okay, let's say 0 0 50, and I hit compile, and this I can, okay, this is a level blueprint, and there you go, so that's 50, right? So now you can see that as I'm changing the location here, as I'm changing the location on the independent individual axes, it's actually moving. So this is how you read it. So on even begin play, have a delay at of 1 second, and after the second is over, you set the actor's location, which actor, that is the sphere, what location, this location, as you specify. As simple as that. Okay, now Blueprint already has an extensive list of functions to work with. You can also make your own custom functions in the Blueprint editor for individual blueprints, or you can make your own blueprints functions library, which allow you to make a collection of functions that can be reused in any blueprint throughout a project. Okay, so you can create custom, for instance, you can create a custom function called get percentage, which takes in two float variables, a and b, where a is a total value and b is the current value. Now the function divides the current value b by the total value a, and then multiplies the result by 100, and it returns the percentage as a float. So this is pretty much what you will do when you're coding in C++ or C sharp. So you have two values that are coming in, and you manipulate those values, and you spit out some value as a float or anything. So in this case, it's a percentage, so it'll obviously be a float. So you spit out a float from that particular function, and by doing all those little calculations, which we'll learn about, because all the mathematical calculation, all the mathematical operation, arithmetic operations are indeed available inside Blueprint. You can divide, multiply, subtract, add, and so on, right? And after you create a custom function, you can reuse it as many times as you need by simply dragging out the function from the functions tab within the my blueprint tab. From the functions category, you can simply drag and drop. So if I create a function here, and I'll just call it new function, I'll compile it, I'll go back to the event graph, and if I want this function, I'll just simply drag and drop this function here. There you have, this function has got nothing, it just takes in a target, it's got an input and it's got an output. Simple. So I'm going to delete that. Okay, and of course, to create a custom function, this is what I did. I just clicked on this plus function, and I created this new function that way. And also in the node graph, you can see two purple nodes to assign. If I drag this here, you can see these two purple nodes to assign input variables and output variables. And you can define the input and output variable for a function by selecting the input or output nodes in the custom function graph and in the details panel. So if I select this, so here you can select your input. So if I compile this, I can select the input and the output. So if I click on a new parameter, and that's the input, and then I click on a new parameter, which is the output, so that's the return node. So if I hit compile again, I come back here, not here, I come back here, there you can see that this is the new param is the first boolean, and the new parameter, and the new param1 is the second boolean, which is the output. So it takes in something and it outputs a boolean, and this is used for connecting the different nodes itself. Okay, and so now you can script the sequence as you would in any other node graph, but you still need to wire the sequence up to the input and output nodes when you're finished, so that this function can really function. Now you can also create a custom function by selecting a sequence of already placed nodes and right clicking on one of the nodes and selecting collapse to function from the menu, and you get a new function that you can rename. And if you often repeat a sequence of 3 or more predefined functions in a blueprint, there's a good chance that you would benefit from collapsing the sequence to a custom function. So that way you can condense the whole thing. It's almost like if you have written a lot of piece of code in some function, but you want a good chunk of that to go into another function, you just simply copy that, or don't copy that, you cut it and you paste it inside the new function body, and then you simply call that one function as one single line, and it can always be called multiple times. So the same thing. So I believe if I select this and I select this, and then I can say collapse to function, and if I say that, it says, obviously, I mean, I can't do that because delay. Built-in functions cannot be really placed in a function graph. Okay, but it has to be a little more. Let me just compile this first. So if I let's say, let's look at that later. Okay, for now, just understand that you can right click and you can say collapse to function. This is already a function, so there's nothing much you can do about that. Okay, so let's do this. Let's go back to main. Okay, and I'll just hit compile. Let's go back to, I'll save. I believe we can save all. And let's go back to, let's create a new level and default level, and that's the default level. And now let's open, okay, inside, let's open the level blueprint, and as you can see that everything is gone because that was for that particular level. Okay, now, and we can just marquee select these two nodes and hit delete because we won't be needing them now. Now let's click on, right click on the event graph, and we'll select begin play. Okay, that's how we bring in this node, as we already saw. And we'll bring in event tick, and bring that in as well. No, I don't think we'll need tick, so I'll just delete that. Okay, so let's drag a cable from here, and let's just release it, and we'll just search for print string like this. And now let's select the print string. Okay, and now let's change this text to something like hello world. Right, now let's just click the compile button, and we don't want to, okay, that's fine. And rotation can be 1, and the text color can be something like red. Right, and click on compile. Now simple, I just hit play, and I can see hello world. That's just once. Okay, and that's because it's not tick. As we saw in the previous, one of the previous videos a while ago, we printed we printed hello multiple times because we had put it inside the tick function. Now this, because being an event begin play, just happens once, and you could see that out there. If I hit play again, or I hit play from here, you can see hello world, and it'll go away in 1 second. So if you increase the duration, it's going to stay there for longer. So if I say 5 and I hit compile and I hit play, and it's going to stay there for longer before it's 5 seconds and it disappears. Right, so that's about that. And just a little bit about the print string function, and it's not the proper way to communicate with players. So this function is typically used as a debugging tool to communicate with what's happening in a blueprint. And if you want to if you want to send messages to the player, have to use a blueprint HUD class, or we'll have to learn to use the Unreal Motion Graphics Editor, which will come in much later. Okay, and so let's talk about variables now. We spoke about functions, we spoke about events, we haven't spoken much about variables. So variables, like in any other programming language, store different types of data. Out here as well, no different. When a variable is declared or created, the computer sets aside a certain amount of memory depending on the data type. Now that memory is then used to store or retrieve the information at that memory location. Now, different variable types use different amounts of memory. Okay, so there are some variables that store as little information as just a bit, and some store as much as an entire actor, which can be huge. And the blueprints, all the editors are color coded so that you can quickly identify what variable type you need when working with functions. So if I click on a variable, and if I go here and I just, so you can see that all of these variables are color coded. So you got boolean as brown, and all of these are color coded out here. And of course you also have a bunch of other things, like you can create a variable of an actor, and you can create a variable of an actor, or actor can be a reference, a class, an asset ID, class asset ID, bunch of things. I think I did something. All right, let's go back to boolean. All right, so let's just talk a little bit about all of these variable types. So variable type boolean is brown, or what is that? I think it's red, dark red, deep red, and this stores a boolean, as simple as that. It's a 0 or 1, false or true. Then you have an integer, which is I don't know what color that is, green. something a shade of green, that stores any whole round number, such as 1, you have 23, and any of these numbers. So integer is like an integer in any other programming language. Then you have float, again, like any other programming language, it stores any value with a decimal. Okay, and then you have string, it stores text as always. And you got a vector. A vector stores 3 floats. If you're coming in from Unity, you will know that vector 3 is x, y, and z, and nothing different here in Unreal either. It stores 3 floats, x, y, and z. Okay, and then you have a rotator, which is kind of new. Now this is a vector that 3 also stores 3 floats, where x is roll, y is pitch, and z is yaw. So roll, pitch, and yaw are 3 kinds of rotations that you can make on an object. So that's what a rotator stores. It's not really quaternion. If you're coming in from Unity, do not get this confused with quaternion. This is still a vector which stores only 3 floats. Okay, and then you have a transform. Now this is a struct that stores a vector for location, a rotator for orientation, and a vector for scale. Again, if you're coming in from Unity, if I want to draw parallels between the two engines, transform is just like the transform in Unity. Transform in Unity has position, rotation, and scale. This also has location. So in Unity, it's called position, but in Unreal, it's more widely known as location. Even though you can still call it position, but if you recall that we set the actor's location and not set the actor's position. So in Unreal, a transform stores location, a rotator, that's for orientation, and a vector for scale. Okay, all right. And rotator is nothing but, again, 3 vectors. It's still a vector that stores 3 floats. And then you have something called, you also have these objects, and if you can see that here, I don't think you can see that here, but you can store objects which, they refer to an actor in the level, and it stores all its property in memory. Okay, and so a struct, just a simple revision, is short for structure. A structure is a collection of variables of any type represented as a single variable. Now the vector and rotator variables are technically structs because they store 3 separate float variables. Now you can create your own structs in Unreal Engine, but it's kind of an advanced topic, and we won't get into this in this video. But after we are more comfortable using the blueprint editor, we might create one. Now we already know how to declare a variable. You can declare a variable like this, and you can let's say if I'm declaring a float variable or an integer, and you can see that there is no default value out here. Okay, so the default value will only arrive, this only gets editable after you compile. So after I compile, you can now see a text box which you can assign a value to. So I can, if I say 10 and I hit compile, I don't have to hit compile because I'm just assigning a value. Now if I drag and drop, let's say I'll just sever this connection. Okay, and I'll just drag this guy and I'll drop it here, and I'll first first let's say convert now to string, let's say to string. Okay, so I convert this to a string first, and this no, I don't have to sever this. I'll bring this whole thing down here. I'll explain what I'm doing, and then I'll just put this inside here. Okay, and new var is 10, and okay, let's see, I hit compile and I just hit play. They can see 10 being printed. Okay, so of course if I click on this, and if I click on 20 and I hit not 20, not 2, 20, and I hit tab and I hit play, it's still gonna, okay, it's gonna show 20, but it still is asking for compile. That's good, right? So as you can see now, I added a new variable which is an integer. Okay, and I assigned it a default value for called 20. Now a print string, regardless of the language you're using, whether it's C# or C++, print string will always take in a string. So you have to provide it with a string. Now it's an integer, so obviously like in C# you convert it to string, or C++ you convert it to a string. This is a converter that does this is a conversion node that converts a string to an integer, and then this goes into this particular input field, and this is always connected. So on event begin play, a new variable that is set in a variable, an integer variable that is set to a value of 20 goes on and converts itself to a string and connects itself to the in string parameter of the print string function, and the print string function does the stuff and prints it on the screen. Okay, so that's great. So and then you also have variable lists. So every variable type in Blueprint can also store a single value or an array, and a variable converted to an array stores a list of its data type. You can use a group of functions to manage variable arrays to set, get, remove, or add to spots in the array. Okay, and let's try this. I'm going to delete that, and I'm going to try one more function. I'm going to try one more exercise so that this just gets drilled into your head. So I'm going to first delete this, and I'm going to start from scratch so that I can see it again. So let's click on this, and I'll call this my int. Okay, I call this my int, and this is an integer because it takes in from whatever the last variable was. And now let's compile this first, and so that you can get the default value. Now let's set the default value to 100, and like this. Okay, and I can hit compile so that it takes in the value and compiles it. Now let's add an event called event tick. Okay, event tick, and let's connect that. Let's connect this, and let's just say print string like this, and bring it down, and let's drag this guy down here, get, and so now it gets the my int. Okay, and there's a bunch of things you can do here which you won't get into yet. All right, and so now we can drag this variables data pin, and we can just push this inside. We can't push this inside anywhere, so or we can do this. My int is 20. See, the green one always goes into the green one. It cannot go in any other input nodes. That's why it's saying that it will convert integer to float. If I do this, it'll convert integer to string. So the last time what we did was we dragged a wire out, and then we looked for something manually. So there's something that it does automatically. So if I take this cable out, put it inside in string, and then it brings the connector out by itself. Okay, it connects it for you. Okay, I'm going to compile, and inside the event string, event tick. So this is what it does. Event tick connects to print string, and it has to print my int, which has a value of 100 every frame. Okay, and I'm not gonna say print to log. I'll just print to screen, and I hit compile again. I'll just hit play. They can see it's printing 100, 100, 100. Okay, awesome. And so last time we looked at what this node is. So if you click on this node, it says that it converts an integer to a string, and you can see that target is Kismet string library. So Kismet is an older form of Blueprint. So when it came to Unreal Engine 4, so these guys they combined Kismet and Unreal Script together to form a way more powerful visual scripting system in Unreal Engine 4. Okay, so that was about variables, and just a little about event tick. By default, event tick, it executes after every single frame render, that is tick interval 0, and the delta seconds data pin on the event tick returns the amount of time that it has taken to render each frame during that particular tick. And if you are coming in from a coding environment that uses game loop like update loops, you might recognize event tick as the Unreal equivalent to those loops. And of course, you can change event tick updates by clicking on the class settings here. And if I click on the class settings, if I click on this class defaults, yeah, if you click on the class defaults, you can check that here. So you can check the tick interval, and if you go down here, so here is where you change the tick interval per second. So right now it's 0, just fine. So you can change that out here, right? So that was about this particular video on variables. When we return, we'll talk about operators and conditionals and how to create them. All right, I'll see you in the next video. Thank you. Welcome back. So all coding environments make use of events, functions, variables, and conditional operators, as you know. So let's introduce you to some of the core concepts that are used in Blueprint as well as the other coding environments, which is pretty much they almost pretty much have an overlap on these concepts. So the first one is events. Again, most or all the programming languages use them, and blueprints in Unreal 4 actually are based on events. And an event is something that happens during gameplay and can be anything from the player pressing a key on the keyboard or upon entering a specific room in a level to an actor colliding with another actor, or even the game starting or the game updating or the game ending. All of these are events, and most events fall into common categories. Okay, and events are used to initiate a sequence in Blueprint. So this is used to initiate a sequence. So if I connect this to a print string, that's the sequence created right there. And when an event is fired, a signal is sent out from the event's execute out pin. It travels along this wire and it processes any function that it encounters along the way, like print string. Okay, so to reiterate, it's pretty simple. When this event gets fired, a signal is sent out from the event's execute out pin that travels along a wire and processes any functions that it encounters along the way. So for instance, if I delete this and I bring in tick, event tick, I bring this event back, and let's say I just say print string, and it just prints hello, and it prints print to, I don't want it to print to log, and I text color is okay. All right, let's see. So if I compile this and if I come back here and just hit play, and you can see this that it's firing. So as I was talking about, now when an event is fired, so this event tick is getting fired and a signal is being sent out. So these are the signals that are being sent out from the event's execute out pin, from this pin that travels along this particular wire, and it processes the print string function that it encounters along the way. So if this had some other if this had a wire going out from its exec pin onto some other function than that event, now this function will fire and it will travel the signal through the wire that's connected to that particular node, and you will also see something like this happening. And when the signal comes to an end of a sequence of nodes, the signal is lost because there are the cables connected from going out from print string connecting any other nodes for the signal to be carrying forward. All right, so I'm just going to stop that. Okay, and you can see that all of these hellos are printed, they'll just go away. All right, so first you have a begin overlap. Okay, I'm just going to get rid of this, or yeah, I'm just going to get rid of this. So you have an event called begin overlap. We don't have that here. That's because overlap, we can't find that here. That's because you have to select something like let's say a flow, I guess, and then I say overlap, and there you have add on actor begin overlap and add actor end overlap. So begin overlap fires when the collision hulls of two actors overlap, and it's assigned to an actor or a component. All right, and then you have the end overlap. This fires when the collision hulls of two actors stop overlapping. So when a guy walks into a volume or a trigger volume, so begin overlap takes in, begin overlap begins, and begin overlap is fired, and whatever function has been, whatever function this triggers gets called because of this trigger. They get executed, things happen, and then when the guy walks out of the trigger volume, then this thing gets called, this thing triggers, and whatever cleanup operation or whatever thing has to be done based on the developer himself, that takes place. So pretty much the same as other programming languages where you have a begin overlap. So you can imagine this as an event which is inside C++, which is called on actor begin overlap and on actor end overlap. Okay, and the body of the code containing the content of the code itself, the behavior of the different actors, desired actors, right? And then you have something called hit, which fires when the collision hulls of two actors. So if I click and if I say hit, so you have add on actor hit. So this fires when the collision hulls of two actors touch, but they don't overlap, just touched. Okay, and this is again assigned to an actor or a component. So if you see that I have selected flow, that's why I'm getting all of these context sensitive events and functions. Okay, and then you have begin play. Begin play is not, doesn't have to be context sensitive, but this is just an event. So when I click on this, just like I brought in a tick, I can also bring in event begin play, and I can fire this event, and I can connect this to different nodes, and I can create my own logic if I want to. And then you have end play. End play, there you have add on end play. This is actually for the flow. You can say on end play. So you can say, yeah, so that's event end play. There you go. This is a generic event end play, not for the flow. Okay, and so these are the 5 common events that are used, and there are 3 more, where you have destroyed, which fires when an actor has been removed from memory. Then you have tick, which we just saw a while ago, where we connected that to a print string that fires with every tick of the CPU. Then you have something called custom, which acts as the user has defined it to work based on tailored needs. Now, some events need specific actors or components assigned to them, such as collision events. It is likely that more than one collision event is being broadcasted at a time. So, for instance, if you have a box trigger actor and a sphere trigger actor in your level, and you need each of them to respond when other actors overlap with either of them, you need to assign each to their own on actor begin overlap collision event. And being able to have events assigned to specific actors allows you to script each actor's individual responses. So to assign an actor in a level to a collision event, you select the actor in the level, and then you right click in an empty location anywhere in the event graph of the level blueprint. Then in the blueprint context menu like this, you can type on actor begin, on actor begin, or on actor begin overlap. So these actors are also inside collision, and you can see all of these events that we just spoke about inside the collision category. And inside the game category, you will find a bunch of, and 2 other you can find a bunch of events out here: on take any damage, on take point damage, on destroyed end play. And under input, when you go to mouse input, so there are a bunch of things on touch input, so what happens when the floor is touched, and so on. And again, once the collision event node is placed, you can see the actor's name that is assigned to the event node. So if I say add event collision, so you can see that the actor's name has been assigned to the event here in brackets. It's called flow because we brought it in for flow, right? And when the actor's collision hull is overlapped after that event we placed, the collision event node executes. Now, components, you also have components in Unreal Engine 4. Like, these are components where you can say you add component, and these are all the components. Now, for this particular flow, you have a static mesh component attached, so you can add as many components as you like to make it a chain of components, right? We won't be covering that now. We'll be covering that a little later. And while the blueprint editor provides predefined event nodes, you can also create your own custom events that can be called at any point in a blueprint sequence. And creating a custom event allows you to define the name of the event and any data that is passed when the event is called. So you have event begin play and on actor begin overlap that call a custom event, and pass a string variable. And then the custom event will receive the signal, and it can use any function like a print string function to display the received string data to the screen. Okay, and custom events can help you manage and organize your blueprints if you want to create those custom events. So to make a custom event, you have to right click anywhere in the graph, and inside the blueprint context menu that comes up, you just type in custom, and then it says add custom event, and you give a name for the event. So I can say something like my custom event or something like this. And there you can see that if you go over to the event graph, you can see the my custom event. All right, now the my custom event, you have a bunch of things that you can do. You can say call an editor, you can say replicates, whether it runs on server, which is kind of advanced. We're not going to get into that. And then you can click on a new parameter, and you can click parameters here. What events do you want? Do you want this to be Boolean? All of these are variable types, which we will cover in a while. And and then you can also assign a variable to the event. So we can select the node, we can add a variable, or you can even assign a variable. And after we have made a custom event, you can call the event from another sequence by opening the context menu. So if you can't double click this because it's not a function, by you can open the context menu and type it in the search box by hitting right click. In the context menu, you can, in the search box, you can type for let's say my custom event. So there you can see my custom event, and it's got nothing but it's got no variable. So if I add a variable here, let's say I'll just add a variable for the sake of it, and it's a Boolean, and the default value, I don't know, pass by reference. Okay, so I just hit compile. When you hit compile, there you go. And now when I click on my custom event, and they can see that the new param is out there. All right, of course this makes no sense, but whatever, just there. Okay, so I'm going to delete that. We don't need a custom event, and I think I'm going to keep that variable. You might need it. Okay, and obviously you can also select the custom event from the, we don't have the palette here, but if there's a palette here, you can actually drag and drop that onto the graph as well.